Hello students, welcome back to my channel. In this video I am going to discuss in detail about the Bronsted-LowryTheory theory. So Bronsted-LowryTheory theory is completely based upon the proton concept. So based upon the proton concept, we will define what is meant by an acid and what is meant by a base. So according to Bronsted theory, acid is a substance which can donate a proton to the other substance. So according to Bronsted theory, what is meant by an acid? Which can donate a proton to the other substance. So coming to the good examples of Bronsted acid, it includes HCl, H2SO4, HNO3, etc. So let us see how an acid donates a proton to the other substance. So whenever if we consider HCl, it reacts with water. So here what is the nature of HCl? It is an acid. So it donates a proton to the water. Then it results in the formation of H3O plus Cl minus. So here acid is donating a proton to the other substance. So HCl will be called as an acid. Next, coming to the base. Base can be defined as a substance which can accept a proton from the other substance. So according to Bronsted theory, base is a substance which can accept a proton from the other substance. And the best examples are ammonia, water. Here we can consider the anions Cl minus, SO4 minus 2, etc. HCO3 minus. Let us see how a base will accept a proton from the other substance. So let us consider ammonia. So whenever ammonia is treated with water, then what happens? It is capable of accepting a proton from the water. So ammonia is acting as a base. So acid means capable of donating a proton. Base means which is capable of accepting a proton. Coming to the neutralization reaction. Neutralization reaction means a reaction which involves the transfer of a proton from an acid to a base. Let us see one best example. So whenever HCl is treated with ammonia, then what happens? Here HCl being an acid, it donates a proton to the ammonia. Ammonia is a base. Then it results in the formation of ammonium ion plus Cl minus. So it is good example for a neutralization reaction which involves the transfer of a proton from an acid to a base. Here we can study one important concept, that is conjugate acid-base pair. So the important concept of Bronsted acid-base theory is conjugate acid-base pair. So let us consider one simple example, that is whenever if we consider HCl, it dissociates into H plus Cl minus. So no doubt at all HCl is an acid. So it donates a proton. With the result what happens? It results in the formation of a conjugate base. So conjugate acid-base pair means an acid-base pair differing by one proton. Let us see one more example. Here we will consider a base, that is NH3. So base is capable of accepting a proton. So whenever a proton is added to ammonia, it accepts a proton and then it results in the formation of NH4 plus, and it is called as a conjugate acid. So when we carefully observe the formula of ammonia and ammonium ion, they are differing by only one proton. So let us examine HCl and Cl minus. In the similar way, NH3 and NH4 plus. So HCl and Cl minus are differing by only H plus ion. Similarly, ammonia and ammonium ion are differing by H plus, and hence these are called as conjugate acid-base pairs. Let us see one more example. So, whenever HCl is treated with ammonia, then what happens? HCl is an acid, whereas ammonia is a base. Then what happens? A proton will be donated to ammonia. Then it results in the formation of ammonium ion and Cl minus. So here from HCl, it is an acid. It results in the formation of a conjugate base. So this conjugate base is obtained from acid 1. So it is called as conjugate base 1. And this base accepts a proton from HCl and results in the formation of a conjugate acid. So it is called as base 2 and it is called as conjugate acid 2. So in this way we can easily identify the conjugate acid base pair in the given examples. So HCl and Cl minus are conjugate acid base pair, whereas ammonia and ammonium ion are another conjugate acid base pair. Is it clear about the conjugate acid base pair, students? And also remember the fact that always when we consider a strong acid, then it results in the formation of a weak conjugate base. So whenever if we consider a strong acid, no doubt at all HCl is a strong acid, then it results in the formation of a weak conjugate base. In the similar way, if we consider a weak acid, then it results in the formation of a strong conjugate base. So it is the conjugate base, but remember that this conjugate base is formed from the weak acid. So this conjugate base is strong in nature. So from the weak acid, it results in the formation of a strong conjugate base, whereas from the strong acid, it results in the formation of a weak conjugate base. Is it clear about the nature of the conjugate base formed from acids? Strong acid gives weak conjugate base, whereas weak acid gives strong conjugate base. Next, we will discuss about the strength of acids and bases. So when we consider the strength of acids and bases, so all the acids can be classified into two categories: strong acids and weak acids. And the bases can be classified into strong bases and weak bases. So strong acid means an acid which is having greater tendency to donate a proton. So an acid which is having a greater tendency to donate a proton is called as a strong acid. And the good examples are HCl, H2SO4, HNO3, perchloric acid, etc. So, in the similar way, what is meant by a weak base? Which has less tendency to donate a proton. And good examples are acetic acid, HCl, carbonic acid, boric acid, phosphoric acid, all these are weak acids. Coming to the strong base, a base which has greater tendency to accept a proton is called a strong base. So, strong base means it is having a greater tendency to accept a proton. Here we have to consider weak acids. So, from the weak acids, we can get strong conjugate base. So, CH3COO minus, Cn minus, OH minus, all these are strong bases. So, coming to the weak base, a base which has less tendency to accept a proton is called weak base. And the good examples are ammonia. And weak bases can be obtained from a strong acid. So, here we can consider Cl minus, HSO4 minus, NO3 minus. All these are weak bases. Why? They are obtained from a strong acid. Always strong acid gives a weak conjugate base. This is about the strength of acids and bases. Now let us discuss about what are the merits and limitations of Bronsted theory. So, coming to the merits of Bronsted theory, it explains the acidic and basic nature of substances even in the non-aqueous media. So, it explains the acidic and basic nature of the substances even in the non-aqueous medium. And according to Bronsted theory, all the acid-base reactions are reversible. At the same time, it explains the relative strength of acids and bases. So, the important aspect of Bronsted theory is it explains the relative strength of acids and bases. These are the few advantages of Bronsted theory. And coming to the limitations, this theory could not explain the acidic nature of non-protonic compounds. Non-protonic compounds means which do not contain proton or hydrogen atom, such as CO2, SO2, AlCl3, etc. At the same time, it could not explain the acidic nature of electron deficient compounds. So Bronsted theory could not explain the acidic nature of electron deficient compounds such as barium trichloride, aluminum trifluoride, barium trifluoride, etc. And this theory could not explain the neutralization reactions which do not involve the transfer of proton. So according to Bronsted theory, what is meant by a neutralization reaction? Which involves the transfer of a proton from an acid to a base. Let us consider one example. So whenever calcium oxide is treated with carbon dioxide, then it results in the formation of calcium carbonate. It is good example for neutralization reaction, but according to Bronsted, here what happens during the neutralization reaction? A proton should be transferred from an acid to a base. Here no proton transfer takes place. Still it is good example for neutralization reaction. So this is about the Bronsted theory of acids and bases along with the merits and limitations. Now let us discuss the multiple choice questions based upon the Bronsted theory. A solvent which is neither proton donor nor proton acceptor is. So amphoteric substance means it can act as both an acid and a base. So coming to the second option, protonic means it is capable of donating a proton. Neutral means it is not an acid, not a base. So coming to the fourth option, aprotic means it neither accepts a proton nor donates a proton. So here option D is the right answer. The conjugate base of NH2 minus is, this is very important concept. Let us see how to write conjugate acid or base of any compound. So whenever if you consider any compound, while writing a conjugate acid of the given compound or while writing a conjugate base of the given compound, you always remember one fact, that is, so while writing conjugate acid, so A stands for accept a proton. You just add one proton. So what is happening? You just add a proton. So whenever a proton is added to a compound, let us consider RH as the compound. Then what happens? While writing conjugate acid of the given compound, you just add a proton. Then it becomes RH2 plus. And the converse is true with conjugate base. Conjugate base means you remove a proton from the given compound. So you remove H plus. Then what happens? It becomes R minus. Is it clear how to write conjugate acid or conjugate base of the given compound? So while writing conjugate acid, add a proton. And while writing a conjugate base, you just remove a proton. Let us see the multiple choice questions. The conjugate base of NH2 minus is. So here what is the given compound? NH2 minus. And you are supposed to write the conjugate base. Conjugate base means we have to remove a proton. That means it becomes NH minus 2. So in the given compound here NH minus 2 is the right option. So it is option E, NH minus 2. And coming to the next question, what is the conjugate acid of N3 minus? So what is the given compound? That is N3 minus. So here we are supposed to write the conjugate acid. Conjugate acid means add H plus. Then what happens? It becomes N3H. So in the given options, where N3H is present, option D is the right answer. The strongest Bronsted base is, students always remember, perchloric acid is the strongest acid. So its conjugate base is weak in nature. When we consider HClO3, HClO2, HClO, the strength of acid decreases. That means from the weak acid we will get a strong base. That means ClO minus is the strongest Bronsted base. So where ClO minus is present? Here option B is the right answer. Remember students, from the strong acid we will get a weak conjugate base, and from the weak acid we will get a strong conjugate base. Which of the following acts as both Bronsted acid and Bronsted base? So here if you consider NH3, so whenever if you consider NH3, it is capable of accepting a proton, so it will act as an acid. Next O2, it will neither accept a proton nor donate a proton. So when you move to option C, that is HSO4 minus, it is capable of accepting a proton, then it becomes H2SO4, and also capable of donating a proton, then it becomes SO4 minus 2. So in the given options, option C is the right answer. So it can act as both Bronsted acid and Bronsted base. Which of the following is the strongest acid? So when you carefully observe the given options, here acetic acid is given. So it is a weak acid. But when you carefully check the other options, the only difference is 3 hydrogens are replaced by the halogens. So whenever halogens are present in the given acetic acid, then what happens? These halogens are highly electron accepting groups. So they are highly electronegative, and hence they increases the acidic nature of the acid. So here 3 halogens are present, and we have to identify which one is highly electronegative. So in the 3 given halogens, undoubtedly fluoro group is highly electronegative, and hence this trifluoroacetic acid is the strongest acid. Why? This fluoro group is capable of accepting electron pair more towards itself, and hence this proton can be eliminated more easily, and that's why trifluoroacetic acid is the strongest acid among the given compounds. Which of the following is acidic in nature? So when you carefully observe the given options, all these are hydroxides of the metals. So they are generally basic in nature. And when you move to the last option, that is BOH thrice, it can be written as H3BO3. So it is called as boric acid, and it is acidic in nature. So option D is the right answer. The conjugate acid of H2PO4 minus is, so here we are supposed to write the conjugate acid. Conjugate acid means we have to add a proton, then it becomes H3PO4. So option A is the right answer. An amphoteric substance is, amphoteric substance means it can act as either an acid or a base. So in the given options, first one is ethyl alcohol, which is acidic in nature, and the second one is acetylene, and the third one is water. It is capable of behaving as an acid and also a base. and hence option C is the right answer. Identify the conjugate acid-base pair. So conjugate acid-base pair means they differ by a proton. So we have to carefully examine the given options. So when you observe the option A, it is not at all called as a conjugate acid-base pair. B is not a conjugate acid-base. Also C is not a conjugate base. But when you move to option D, they are differing by only one proton and hence can be called as conjugate acid-base pair. So option D is the right answer. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.